depends on what you like to scan with. This is what I try actually to say also about it in my presentation. Generally speaking, first of all, sometimes we work with centers who like to modernize their work facility. And then the first question we will have is what kind of demand in which area you have. You are more prosthetists, you are more orthotists, you are lower limb, upper limb based. So that's the question, because let's say I give an example, you like to do upper limb prosthetics. So an upper limb is always smaller than a lower limb device. So you need a scanner who can capture medium to small sizes. Yeah. And if you have, for example, more cranial patient, they are always moving. So you need a different scanner who is different from the accuracy that you're capable to capture the moving skull of a baby. So I cannot generalize the scanner as good or bad. It has more to do, and this is maybe a very deep answer, is it has to do with the software. Because most of the people think that it's actually the camera and the scanner themselves, and it has to do with the data, how it's processed. So that means the software, what is used with the scanner, is actually the key of scanning in a different way. But the scanner and the size, what he's capturing, has to do with the cameras. That means the distance, the field, what the scanner is capturing, and the frames per minute, how fast it's capturing or how slow, so higher details, lower details. So this question can only be answered if I know exactly what the guy is trying to do with it, and then we can answer here the question accurately.
Charl, Rahul, would you like to add anything based on?
I think it's rightly said by Sofyen that it depends upon what sort of devices you are looking. What is an outcome of that particular scanner? There are a lot of scanner, because what happens in 3D printed, you receive the final device from your manufacturer. So you need to ensure that whatever morphology you are capturing, that's your final data. If you have a lot of soft tissue compression, which is required, and then you do a direct scan onto the limb, and then you receive the final product, end of the day, that's not gonna clinically justifiable to the patient. For small devices, of course, people can use in their practice as a structure, or I personally use TechMed's body scan, which I have found very sustainable when it comes to a cranial scan or upper limb or lower limb prosthetic scan. But nowadays, I think even with your mobile phone, with your iPhone, latest iPhone, you can use the front end through that camera technology and do some bit of scanning practice. For example, comb and 3D size me. Just good to start with somewhere down the line, and then you can decide which area you want to become more expert in, and then choose your scanner precisely.
Yeah. So the thing to remember is irrelevant of what scanner you use. It's only a scan. It means nothing because you have soft tissue morphology. So every patient has morphology. So step into the shoes of the guy doing the CAD modification, or it's you yourself. So it's always going to be your scan, and then it's going to be measurements. And measurements is going to use different tools. It's going to use ML sticks. It's going to use tape measures of different widths so that you can get soft tissue compression, because you need to do volume reductions. So something like a structure scanner, again, super cost effective. You can use that for very advanced orthotics and prosthetics, and it's been proven. There's people providing very accurate devices using a structure scanner as long as they coincide it with detailed measurements. You know, a lot of companies actually only need detailed measurements to do very sophisticated AFOs and even prosthetics, specifically above knee prosthetics. But if you're looking at high definition silicone work, the TechMed scanner is very cost effective, the body scanner. It actually, you can do silicone partial hands. And then you look at a scanner like Shining. Shining is a cost-effective scanner. It works very well. It's the software is very good. So it depends on what you need, but I think it gets down to what can you afford. And then it gets down to how precise are you. If you've got a TechMed scanner and that's your first stepping stone, into the realm, then embrace that. Get yourself an iPad, get a scanner, start understanding STL file formats, OBJ, start using free software, start understanding the scanning process, start taking measurements, start using a central fabrication facility of choice, explain to them what your scanner is. They've got very accurate parameters on all the scanners, and they can tell you what the differentiation of accuracy is at 3%, 8%, you know, and they can play around with that. Remember, at the end of the day, it's by sections, how accurate you are. So even if the scanner is 100% accurate and your R1 and R2 range on your spasticity measurement on your child was incorrect, that still has to be corrected on your actual design. So that three-dimensional foot has to be changed. It's never 100% accurate. So you have a bisection in loss of accuracy of your scan. You have a bisection of loss of accuracy in your measurements. So there's several factors at play. But start, don't wait. Get yourself the most or the best scanner you can afford and start playing.